Okay, so in this video, we're going to talk about relative and max and mins. And so we're going to take a function here, and we just got a graph. And so definition, relative maximum. So the relative maximum is the highest y value close to the x value that produces the maximum. All right, so what do I mean by that? So highest y value, so relative max doesn't mean it has to be the absolute max, but it's the biggest x or the biggest y value, the f of x. So y value is like f of x around some interval of x values. So like for example, with this graph right here, okay, considering all the x's in this value here, the biggest y value is this one right here. So that would be a relative maximum, all right? Are there any other relative maximums? Well, this looks like that's about as low as you can get. This one right here, though, looks like, considering only the x values around it, looks like it's the highest y value, right? Like it's not necessarily the highest overall. Clearly, this first one that we had is a higher maximum, but it's relative to the x values around it is how I like to think about it. So that would also be considered a relative max. It's a cusp whenever it makes that sharp turn like that. That's what we're talking about. And then over here, that's definitely a relative max, but it's a little bit stronger than a relative maximum. When we look at this one here, with this graph here on this interval here that the function f is defined for, it looks like this is actually the overall the highest y value, and we call that the absolute maximum. So the absolute max. So if you were asked to find the absolute max, that would be the absolute maximum there. All right, it's the highest y value considered on all these x's in this range here. Okay, it's the biggest one. Now, what about relative min? Okay, so this is the lowest y value close to the x value that produces the minimum. So we're looking for the low values, okay, relative minimums. Now, this one right here, why would this not be a relative minimum? Well, because it's an open interval there on that end, we can get as close as we want, but we can't actually attain this value. So maybe that's at -1. So maybe we could get like -0.99999, right? But we can't actually plug in -1 because it's not defined. So we can't actually attain that relative minimum there. So that is actually not one. And we talked about that in another video where we talked about it needed to be a closed interval. It couldn't be an open interval. There's no minimum on those endpoints for the open interval. Looks like the lowest point. All right, so what is a relative minimum? Well, we've got a relative minimum here because all the x's in this range in here looks like this looks to be the lowest one going on both sides. So that's and it actually ends up being the most minimum one. And one way you can do this is you can just draw a line through and you see, look, the graph never crosses it never dips down below that point there. That's the absolute minimum. Okay, so the absolute minimum going on right there. All right. Now, another minimum looks like maybe around here, maybe. Okay, yeah. And so this is a relative minimum here. All right, smallest y value around a close interval of x's close to that. Okay, so we've got a little theorem here, or a definition for critical numbers. So what are critical numbers and then critical points? Okay, so let f be defined at c. Okay, so we have some function that's defined at a point C. The value C is a critical number or critical value. Okay, so critical number, critical value, those are the same thing. Okay, of f if the derivative evaluated at the point C equals 0, or the derivative is not defined. So I also say D and E does not exist is a shorter way saying undefined or not defined there. It does not exist at that point. Okay? So if you take a derivative, and the derivative, when I plug in the C number, equals 0, or it does not exist, it's undefined at that point, then that tells me that I'm dealing with a critical point. Okay, so if the number C is a critical number of F, then the point is a critical point here. All right? Okay, so we are not saying, all right, we're not saying that all critical points produce relative extrema. We're not saying if it's a critical point, then it's a relative extrema, right? What we're saying is if it's a relative extrema, it's a relative max or min, then it has to be a critical number, critical point, all right? This is very different, okay? It's like, well, golly, if there's fire, then there's smoke, right? Okay, if you have a fire going, there's going to be smoke. If fire, then smoke. But if I say if smoke, then fire, that's not always the case, right? Because you could have something smoking, but there's no fire, right? So maybe the fire's already burned out and then there's just smoke coming up, right? But if you have a fire, then it is definitely the case that the fire will produce smoke. That is a direct result of the fire. But if you have smoke, then that does not mean necessarily that there is a fire. There could be a fire, but there might not be a fire, right? If you see smoke, okay? So it's an if-then statement, all right? So you can't work it around both ways, okay? It only works one way. So we are not saying that all critical points have to produce relative extrema. So if I go through here and I see where is the derivative equal to 0 or where does it not exist, that will give me a list of potential relative maxes and mins, and I check those, but that's all it does. It doesn't tell me that it's a max or a min. I have to check, all right? So we see here with this first one, this is a relative max. We found that already, okay? So we see that the derivative here is the slope of the tangent line, right? That slope there is equal to 0. That is exactly what we're looking for. The derivative evaluated at the point is 0, okay? All right, looking here at this absolute minimum, looks like the slope again is a slope of 0, so we're good there. What about this cusp here? I mean, is the slope 0? Is the slope positive? Heck, is the slope negative? We just don't know what the slope is, do we? Okay? This slope, this cusp here is actually, the slope is undefined at this particular point here, okay? Maybe it's like a positive slope on this side, but it's a negative slope on this side. Well, what do we know? For a limit to exist, the left and the right side have to equal each other. Well, there's no way a positive number can equal a negative number, right? So that's not going to work there for us, okay? So this slope here is undefined at that cusp, right? So the derivative does not exist, right? So that would be this scenario right there if the derivative does not exist, okay? Here we see another 0 slope, all right? And then what about here? This right here, my friends, is an example of what I'm trying to illustrate here with the whole point of this. We're not saying that all critical points produce relative extrema. Clearly, this point here has a derivative equal to 0, okay? The derivative is equal to 0 here, evaluated at this point. Now, is this a critical point? Well, is this a relative maximum here or a relative min? If I look at this, values on the right side are bigger and values on the left side are smaller. So it's not a relative max, it's not a relative min. Okay? So just because you have a critical point does not mean that you're going to have a relative max or relative min at that point. But if it is a relative max or a relative min, right, then you know without a doubt that it will be one of the critical points. Okay? So this scenario here would not be a relative max nor a relative min. So that just illustrates for us that we're not saying that all critical points must be relative extrema. Okay, this is an example of a critical point that is not a relative max or a relative min. Okay, so to illustrate this in a theorem, all right, there's a theorem, and this theorem says it's a 3.1.2, and it says let f be a function defined on some open interval, and if f has a relative extrema at c comma f of c, okay, so there's some relative extrema, maybe it's a relative min or a relative max, we don't know, it's just something, then what do we know? C is a critical number, okay? So what is this saying? It's saying that a relative max or min implies that it's a critical number, okay? What we're not saying is this. We're not saying if I have a critical number, then automatically we have a relative max or min. Okay? That is not what we're saying here. This is wrong. All right? But this is the theorem. If I know that there's a relative max or min, then I know, okay? Then I know for sure that those are going to produce critical numbers. That's what I'm saying. Those are critical numbers, all right? Very different than trying to say if it's a critical number, like here, 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 and here, right? Okay. If it's a critical number, then it's a relative max or min. The example right here illustrates that that could be false. This is a critical number that is not a relative max or min, okay? Hopefully I didn't beat that into the ground too much. Just stressing it because that's probably one of the things that students get confused with. So the converse is not always true, okay? So when I think about the converse, what I'm thinking about is, hold on a second. All right. So when I say converse, it's like if P, then Q. The converse of this would be if Q, then P. Okay? That's what I mean by the converse. We just swap the hypothesis with the conclusion. All right, guys. Hopefully this video was helpful for you.